Okay, so now we're going to look at the operations of the fractions. It's easier to start with multiplication and division than addition and subtraction. Addition and subtraction actually has a lot of conditions that need to be met in order for you to do them. So let's say we had, we'll start off simple, say 3/5 multiplied by 10/6. Okay, the first thing that you want to do, and we're assuming now that you don't really have a lot of trouble with simplifying the fraction, is we want to see if we can simplify before we multiply. Okay, and so I'm going to write just a generic form, AB over CD, and what we're looking for is the cancellation of a top and a bottom. Okay, top and bottom of the same number, but it doesn't matter whether that top and bottom is here, if the top and bottom is there, or if the top and bottom happens to be crisscross, or it could be crisscross. Any of those combinations can work. What you are not allowed to do, though, is you're not allowed to cancel out the same numbers that happen to be here or here. That's no good. Okay, and so what I mean by that is, and we're going to focus on the number 3. 3/5 multiplied by 7/3. If you notice, I do have a top and a bottom, so this would cancel out. Okay, or if I had, say, 3/3 times 7/5, top and a bottom, that cancels out. Or if I had, say, 7/3 times 3/5, that 3 and that 3 cancels out. That's allowed. Let's see, what other combination can we have? 5/7, 3/3. That cancellation is allowed because, again, it's a top and a bottom. What you are not allowed to do is you're not allowed to cancel out side to side. So this would not simplify. All right, so looking at the 3/5 times 10/6, 3/5 times 10/6, I just rewriting the problem. What I'm looking for is to see if there's any combination of the top and the bottom that simplify. Well, it's exposed. It's a lot better if I can write the prime factorization form. And so 3/5, they're both prime numbers, but 10 becomes 2 times 5, and 6 becomes 2 times 3. And remember, again, I'm looking for a top and a bottom. So I see this 3 cancels out with this 3. This 2 cancels out with this 2. And the 5 cancels out with this 5. Meaning that everything canceled out, meaning that I have just 1/1, which reduces to 1. Now, why is it that I have a 1? 3 divided by 3 is 1, 2 divided by 2 is 1, 5 divided by 5 is 1. So all you're left with is a 1. Okay. How about if we had, say, 4/10 multiplied by, let's say, 25/16. Okay. Well, again, I want to put these in prime factorization form, and that is 2 times 2, 2 times 5. That's 5 times 5, and then 2 times 2 times 2 times 2. Again, you'll get better at this with practice. All right, so writing the prime factorization form, multiplication says go look to see if there's anything that simplifies. Well, I could do this 2 and this 2. I could do this 2 and this 2. Why am I allowed to do that? Because it is a top and a bottom. These 5s I cannot do because they're side by side, but I can do the top and the bottom. And then this 5 doesn't really simplify with anything else. Those 2 are side by side. And so now that I've simplified everything, now what I'm going to do is I'm going to multiply across and get it out of prime factorization form. So that's a 1, that's a 1, that's a 1. 1 times 5 is 5. On the bottom, that's a 1, that's a 1, that's a 1. Remember, when they're canceled out, they're considered ones. 1, 1, 1. Then 2 times 2 is 4, times 2 is 8. So my solution to 4/10 multiplied by 25/16 is 5/8. This might not look a lot familiar to you. And the reason is, before we learned multiply across and then simplify. But look what happens. 4 times 25 is 100. And then 10 times 16 is 160. The problem with this solution, and you're probably a lot like me, is that we would write this answer and then it would be counted wrong because we didn't simplify. And so our technique for simplifying was, oh, well, think of a number that divides into both. Okay. All right, I would do that. And, well, they both divide by 10 because they have a 0 at the end. So that becomes 10/16. Again, we're thinking, all right, I simplified it. I'm done. Get our paper back or a quiz back or our test back and figure out that this was wrong because it didn't simplify all the way. And made you think, well, make up your mind. How many times am I supposed to simplify it? And so we got to the point where we didn't know what the finishing product was. All right, fine. It reduces both by 2 because this is even, this is even. 10 divided by 2 is 5. 16 divided by 2 is 8. And so finally we get to that 5/8. My approach gets you there faster without any of the guesswork. You take the simplification problem and you do that first. And then you multiply, and you don't have to worry about this simplifying any further because you're taking care of the simplification part first. Okay, so try some problems. Now before I do that, I'm going to do a quick tutorial on how to do the division because division actually happens to be extremely easy in the fraction universe. Let's say we had 3/5 divided by 9/25. The very first thing that you're going to do with any kind of division problem is you're going to turn this division into a multiplication, and then you're going to reverse these two numbers. And so what we're doing, it's what's called multiplying by the reciprocal. So once you do this, then it again becomes just the basic multiplication problem, which means put them in prime factorization form. They're already there. The 25 becomes 5 times 5. The 9 becomes 3 times 3. I'm looking for things that simplify, such as this 3, this 3, this 5, nothing else. And so it becomes 1 times 1 times 5 is 5. 1 times 1 times 3 is 3. My final solution is 5/3. Right? So here's some practice problems. In fact, what I'm going to do now is I'm going to take a picture of a couple of exercises that you should try and try those out. And I'm also going to send you the solutions whenever you feel like you're comfortable. Okay, I can do this. Then let me know, and then we'll move on to the addition part. Okay?